little fan in summertime and you only need around 4.5 volts in it. So I'll give you a cell, one of those batteries, it's around 6 volts, but you need 4.5. What are you going to do? Can't use it, can you? But you can. A-level physics students should be able to tell me how. And that's what potential divider is. So you've been learning potential divider from GCSE, right? Do you remember, if that's 6 volts, yeah, and let's say I have 2 resistors connected in series, 3 ohms, 3 ohms. Without working things out, Jaden, what would be the voltage here? What would be the voltage here? 3 volts, 3 volts. Let's do the same thing. 6 volts. Now this is 2 ohms, and this is 4 ohms, and that's 6 volts. So, Arsh, what would be the voltage here, and what would be the voltage here?
Would be 4 volts and 2 volts.
So you're saying that?
Yeah.
Right. You got something right, which means that these voltages, the main EMF, the power supply, would provide 6 volts across it. But actually, this will be 2 volts and this will be 4 volts. And I'm going to prove that to you in a minute. But I want you to see that the voltage here is directly proportional to the resistor. So, how do we do that? GCSE. What's the total voltage, Arsh? 6 volts. What's the total resistance? 3 plus 3, 6 ohms. So what will be the current? V over R, 1 amp. If the current here is 1 amp, what's the voltage? 1 times 3, 3. 1 times 3, 3. Likewise, the current is still, the voltage is the same, the resistance is the same, so the current is still 1 amp. 1 times 2, 2. 1 times 4, 4. Using that same analogy, how do you get to the next one? If this was 12 volts, what could I do? If this was 2 ohms, this was 4 ohms, and then this was 6 ohms. How would the voltage change? Let's do it. Total resistance, I've deliberately made that 12. So then you have a current of, voltage is 12 volts. So current is 1. 1 times 2, 2. 1 times 4, 4. 1 times 6, 6. So what can you see? You can see that the fact that you can change the resistors, it affects the voltage. Potential divider. A potential divider is a circuit that you can split a bigger potential into smaller potential by changing the resistors. Right, so what do they do in exam? A-level, they flip it. This same circuit, I want you to look at it like that. 12 volts. 2 ohms. 4 ohms. Isn't that what you're seeing in questions? This is what they look like. Right? Here's the other thing now. That's still my 12 volts. Look at this now. This 12 volts has got a potential of 0 volts here and 12 volts here. Yes or no? If I put my voltmeter right in the middle, and this is like a variable rheostat. Let me show that to you. Our variable rheostat. Halfway, what's the resistance? Remember your thing that we did earlier? Half and half. So if I have it here, what will be the voltage here halfway? 6 volts. What will be the voltage here? 6 volts. But the beauty with that is, if I have it all the way down, what's the resistance? 0. What's the voltage? 0. And I can go up in very, very, very small increments. Does that make sense? That's what potential divider is. Potential divider is, instead of now, earlier I showed you, I did it like this, didn't I? I had 2 resistors. So by changing these resistors, it affects the voltage. But a potentiometer, or what would you call here, a variable rheostat, is very good at doing that. So you can tap out, you can slide it gently. And how am I changing the resistance here? Your 12 stuff, R is equal to rho L over A. By changing the length, resistivity of the material is the same, area cross-section is the same. By changing length, right, number of coils, I've got more resistance. It doesn't finish here. I'm going to add one more thing. The general equation now. So instead of writing 12, I'm writing EMF. And R1, R2, R3. If I said to you what's the voltage across V, R2 here, be V2. I've asked you from year 12, I showed you how to do it, but I asked you to memorize. The equation V is equal to the resistance directly proportional to it, multiplied by the EMF, divided by the whole resistance, R1 plus R2 plus R3. To be honest with you, this is simply V is equal to I. Oh, isn't that the whole current? What's the current? It's the whole EMF, the whole, over the whole resistance. The total resistance is what? Have you seen this in questions?